Hi, this is Mrs. Williams, and today we're going to cover inductive and deductive reasoning, along with a few problems on vertical angles and supplementary angles, how to solve those types of problems. So let's get started. The directions say, state whether each of the following is an example of inductive reasoning or deductive reasoning. So the key thing to keep in mind, inductive reasoning is reasoning where you use specific examples or a specific case to make a general conclusion, and deductive reasoning is kind of the opposite. You're going to use general information to make specific conclusions. And deductive reasoning is what we use in proofs. When you use deductive reasoning, it's going to be factual all the time. It's going to be proven. Inductive reasoning, it might be true, but it's not really proving that it's true. It's a good way to start an idea to get to a proof. It's kind of like a theory, as we would say in science. Helps us, think logically and make some good ideas, but it's not hard and fast proof like deductive. So let's take a look at number 1. It says, Bess observes that whenever she sees a sports car convertible, its driver is wearing sunglasses. Bess concludes that anyone who drives a sports car convertible will be wearing sunglasses. So there, Bess is using the sports cars that she's seen, and maybe it's quite a few sports cars. It doesn't say the exact number, but either case, she's using a specific number. Maybe she's seen 100, maybe she's seen even 1,000 sports cars, but she hasn't seen them all. And so that would be an example of inductive reasoning. She's using specific data. She hasn't seen every single sports car. So that's, even though maybe she's seen a lot, it doesn't say, but even though she hasn't seen all of them, that would be inductive. Because you can't say, yes, every sports car convertible will be wearing sunglasses. And another way to think of it is that if she saw one sports car convertible and the person was not wearing sunglasses, then that's going to disprove it right there. So if you can disprove it, with one example, you know that it's not deductive reasoning. Okay, so let's take a look at number 2. It says, a geometry teacher states that any student who scores at least 95% on the final test will earn an A for the course. And Paulo scores 95% on his geometry final test. So that's going to be an example of deductive, and if you look at the first sentence, it's a general statement. First of all, this first sentence is a fact. It's not really going to be up to debate whether you earn an A overall in the course if you get 95% or above. That's what the teacher has said. That's the rule for the class. So that's a fact, and then and it's for the whole class, so it's a general type statement. It's for everybody in that class, and then here's a specific student that scored 95% on that geometry test. And we know from the first sentence that, okay, he scored a 95% on his final, so he earns an A. And that conclusion that's made there is based on the fact made in the first sentence. So that's deductive. You're going from a general factual statement to a specific case where you can say, okay, based on this general sentence, here's specifically what I know about this case. Okay, let's take a look at number 3. Ron carefully measures each angle of a figure that appears to be a rectangle and determine that every angle measures exactly 90 degrees. Ron does this for several other figures that also look like rectangles and find only 90-degree angles. Ron concludes that all rectangles have 4 right angles. Okay? And we know, that he might be on the right track, that's probably true based on our information we've always, known about rectangles. But you have to be, your question is not about rectangles, it's about the reasoning Ron's using. Is it inductive or deductive? So in this case, it's going to be inductive because he is using specific rectangles. He's measuring them. And again, it's kind of similar to question 1 in that he's using specific examples, he hasn't measured every single rectangle that ever has existed. It'd probably be impossible to do that. And then he's making a conclusion going from the specific examples he's looked at to the general about all rectangles. And so that's inductive, going from specific to general. Okay, and we're skipping to number 7 here. 7 says, Eat Right, a consumer advocacy organization, declares that cereals that contain high amounts of sugar are not nutritious. Wacky Crisps contain high amounts of sugar. Timmy decides that Wacky Crisps are not nutritious. So again, here you're looking at a general statement made. I guess it could be, we know that consumer advocacy things, different studies could change. But for the moment, this is the study that's going on, that sugar cereals that contain high amounts of sugar are not nutritious. So we're going with that as the fact for the time being. And then we are told, okay, specifically Wacky Crisp cereal has lots of sugar, so it's not nutritious. So we're going from general to specific. That's deductive. Okay, question 8. Since all squares are rectangles and all rectangles have 4 90-degree angles, then all squares have 4 90-degree angles. Okay, this is similar to question 3. It's kind of the opposite of question 3. So we're going from a general statement, and it's a factual statement. Since all squares are rectangles, okay, we know that's true, and all rectangles have 4 90-degree angles, then all squares have 4 90-degree angles, okay? And that's actually called syllogism. So you know, if you've learned syllogism, that's a type of deductive reasoning. Okay, so we could, in other words, after this general statement, we could pick any specific square that we might happen to look at and know that it's going to have 90-degree angles, 4 90-degree angles. So 8 is deductive. Okay, 9. A defensive driving course instructor states that every driver must show proof of insurance in order to get a driver's license. Yvonne shows her driver's license to him, and he concludes that she has auto insurance. Okay, so we're going from a general rule. Okay, in this state, you have to show proof of insurance to get a driver's license, and then specifically Yvonne shows her driver's license to him, and so he concludes that she has auto insurance. So that's deductive. You're going from general to a specific case with Yvonne. Okay, question 12. We're going to do some actual going into what vertical angles are, how to identify them. So question 12 says, how many vertical angle pairs are formed by lines M and N? Okay, so we have line M and we have line N. And vertical angles are angles that are right across from each other whenever you have two lines that intersect. So, for example, this angle and the one right across from it, right there, those are vertical angles. Okay, and so that would be considered one pair of vertical angles. And another thing to note about vertical angles is that they're always equal. Okay, that's really important to remember. Okay, let me grab a different color and identify the other pair of vertical angles. So this angle is vertical to this angle. Okay, so those two angles, that one there, and there, those are called vertical angles. Again, just because you have two lines that are intersecting, the angles are right across from each other, and again, those are going to be equal in measurement. And so the question is, you've got to be a little careful. How many vertical angle pairs are formed? The answer would be 2. There's the blue pair and the green pair. Okay, question 15, similar to question 12, identify the vertical angle pairs. Okay, so if we look up here and do part A here, we're looking at angle 3 and blank. Well, angle 1 is the angle right across from it, and so that is going to be paired with angle 3. And then angle 4 goes with angle 2. Those are vertical angles. And don't forget, these are going to be equal to each other. The pairs are equal. So angle 3 is equal to angle 1. Angle 4 is equal to angle 2. So for problem 16, we're going to take that knowledge that we have that angle 4 and angle 2 are equal and apply it. So 16 says, using the figure from problem 15, find the measures of the following angles. So we know that angle 4 and angle 2 are vertical, and they are equal. So if angle 4 is 33 degrees, then angle 2 is going to be the same thing, 33 degrees. And then angle 2 to angle 3. Now, angle 2 and angle 3 are not vertical. We're going to use a different piece of information. Angle 2 and angle 3 are not equal. Let's put 2 tick marks on angle 3 just to show that angle 2 and angle 3 are not the same. But what they are called a linear pair. And if you look at angle 3, I'm going to highlight the sides of angle 3. So here's angle 3. Those are the sides that make up angle 3. And then let's highlight angle 2. Angle 2 is formed right there. So you can see that the orange and the green overlap right here. They share a side. So if you have two angles that share a side, and the other two sides that are not being shared between the two are a straight line, they make up a straight line, they are called a linear pair or a supplementary pair. So you'll hear those two words, linear pair, supplementary pair, or supplementary, that letter P. My supplementary is kind of crazy right there. But that's supposed to, I'm trying to draw a supplementary. Let's try that again. Okay. My bamboo tablet is not cooperating. Supplementary. That looks a little bit more readable. Supplementary angles, or a linear pair. And what you want to remember about those two are that either one of those, no matter which way you name it, those two, if you put those two angles together, they're going to add up to 180 degrees. So what we're going to do for part B is we're going to make a little equation. I'll write it over here. We're going to say the measure of angle 3 plus the measure of angle 2, because they're a linear pair or because they're supplementary, those are going to add up to 180 degrees. And then I'm going to put in what I know about angle 2. I know angle 2 is 65 degrees. So I'm going to say the measure of angle 3 plus. I'm going to do some substitution. If you were doing a proof and you had to give a reason for this step, you would put substitution in there. It's going to equal 180 degrees. And then I'm just going to solve for angle 3. That's what I'm trying to find, right? So you're just going to go back to Algebra 1 and subtract 65 degrees. And those will cancel. You're going to get that the measure of angle 3 is 115 degrees. Okay, so that's how you would do a problem where the two angles, since they're next to each other and they share a side, and the other two sides make a straight line, they're a linear pair or supplementary. Okay, so 19, we're going to identify the vertical angle pairs. I'm going to scroll down a little bit. I didn't have enough room for the directions and the problem. So for part A, we're looking at angle 4. So keep in mind that vertical angles are formed by two lines, two intersecting lines, and they're just the angles right across from each other. Okay, so we're looking at angle 4, and we want to look at the angle right across from that, and so that's angle 10. That's going to be the vertical angle to angle 4. That's going to be the vertical angle pair. So we put angle 10 right there. Okay, part B, we're looking at angle 5. Here's angle 5. The angle that's right across from it, where those lines intersect, is angle 8. And that's the vertical angle pair, so angle 8. Okay, and then angle 6. Up here. The angle that's right across from that is angle 12. And the reason I'm putting additional lines there is just I don't want to show that angle 4 and angle 6 are equal. I'm just trying to show that the vertical angles across from each other are equal. 5 and 8 are equal, 4 and 10 are equal, and then angle 6 and angle 12 will also be equal. Anytime you have vertical angle pairs, they are always equal to each other. And that's all you had to do on that one, was just identify them. Okay, now we're going to take a look at problem 20, and I have problem 19 here because we need to use it. And we're going to find the measures of the following angles. So we are told in part A that measure of angle 7 is 135 degrees. So let's put that on our picture. And we are wanting to find angle 1. And if we look at angle 1, it is vertical with angle 7. And so all you have to remember about vertical angles, they're really easy, as long as you remember the fact that they're equal. And so we really don't have any work to do other than to remember that fact. Okay, so angle 1 is 135 degrees. Okay, part B. We know that the measure of angle 11 is 119 degrees, and we're looking for the measure of angle 8. So let's mark that on our picture. We know this angle right here is 119 degrees, which is this angle. We're looking for angle 8, so I'm going to highlight angle 8 as well. If you look at angle 8 and angle 11, they share this side right here. And the two sides that they don't share make a straight line. So they are called supplementary, or another way to say it is that they are a linear pair. And what you want to remember, no matter which vocabulary word you use, linear pair and supplementary, both of those mean that the angles, if you put them together, add up to 180 degrees. Okay, and it makes sense because a line is 180 degrees, right? Hopefully you know that. And so if you rotate through angle 8 and angle 11, you should have gone 180 degrees. So we're going to set up an algebra equation, and we're going to say the measure of angle 11 plus the measure of angle 8 equals 180 degrees, and then substitute in what we know about angle 11. We know angle 11 is 119 degrees. If my equal sign would stick there. I'm not trying to subtract it, I'm putting equals. There we go. And so when I solve for angle 8, all I have to do is subtract 119 degrees, and I'm going to get 61 degrees for angle 8. Okay, part C. The measure of angle 3 is 73 degrees. There's the measure of angle 3 right there. And we want the measure of angle 9. Well, those are vertical. They're formed by two intersecting lines, and they're right smack dab across from each other. So they're equal. So I love vertical angles. They're super easy as long as you remember that they're equal. Okay, problem 27 states that the measure of angle PKM is 13x minus 4. Angle PKM is right there. That is 13x minus 4. And the measure of LKN is 9x plus 14. So I look at those two angles and I say, here's a line and here's another line, and they intersect. And this angle and this angle are right across from each other. Those have to be vertical. And one thing that immediately comes to mind is that they're equal. And I'm going to take that and use that for part A, B, C, and D down here. So first of all, it says find each value. For part A, we're just looking for x. So again, I can just make an equation right here and use my algebra skills to solve for x. And then I'm going to have the answer for part A. So again, I can do this just because those two angles are vertical. I know they're equal. So I'm just going to go ahead and solve for x. Use what I know. So I'm going to subtract 9x from each side, and that will give me 4x minus 4 equals 14. My lines don't seem to want to stay tonight. All right, and then I'm going to get to add 4 to both sides. And that will give me 4x equals 18. And then when I divide by 4, I'm going to get x. Well, let me show that step. Divide by 4. I'm going to get x equals 4.5. Okay, so that is my answer for part A, 4.5. Okay, now for part B, I'm looking for the measure of angle LKN. So let's look at the picture. Here's LKN. Well, I know already that angle LKN is 9x plus 14, and now I know what x is. So I can plug it in, and I'm going to get my answer for part B. So I'm just going to take 4.5 and plug it in there for x. Simplify that. Remember to multiply first and then add, and you're going to get 54.5. So that's my answer for part B. And then you can probably see where part C is headed, right? We're going to take our x value and plug it in over here for angle MKP. So 13 times 4.5 minus 4. Again, multiply first, then subtract 4. Angle C is going to be 54.5, and if you really think about it, I didn't even have to do that, right? Because, remember, this angle and this angle are vertical, they're equal, so since I already did this, I don't even have to plug it in here. I should just know, as long as I'm confident, it is a good way to check and make sure you actually calculated the first one correctly. So if you just want to double check yourself, please feel free. Otherwise, just remember, those are vertical, and you can save yourself some work there. Okay, now, the last one, we're looking for the measure of angle P. So for angle P, what you want to do is you want to look at what angle P is inside of. Right here you have a triangle, and one thing you want to remember about a triangle is that the 3 angles inside of a triangle add up to 180 degrees. We know this angle is 90. Now we know this angle right here is 54.5. And so we can use those 2 facts to find angle P. So one way to write it out is we can say the measure of angle P plus 90 degrees plus 54.5 degrees is going to equal 180 degrees. Okay, and so I'm going to add the 90 degrees and the 54.5 degrees together, subtract that from the 180 degrees. And that's going to give you that the measure of angle P equals 35.5 degrees. And that is your answer for part D. Okay, so now let's try some proofs. Problem 31. Here's your given information. The measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. We want to prove that the measure of angle 4 and the measure of angle 5 are the same. Okay, so let's look at statement 1. We'll go through this. We have our statements. We don't have to think quite so hard if we have the statements already there for us. Not saying it's easy, but it is easier than when you have to actually come up with the statements. So let's take a look at each one as we go. Statement 1. This should always be the easiest one. If you look at what we have right here, it's the same thing as we have right here. And the reason you knew that, over here in your reasons column, is because it was given to you. So all you have to do is write given. Okay, part B here, statement B. Now this gets a little harder. Okay, you have to ask yourself, how did I get, and it usually flows here. Sometimes not. Sometimes you have to go up and look at the picture. So if you look at statement A and the one under it and you're thinking, I do not see how this connects, take a look at the picture, because sometimes it comes, from the picture. But in this particular case, it does flow. So if you look at from statement A to statement B, what happened, same statement except we're missing angle 3. So what happened is that we subtracted angle 3 from each side. So if I do minus the measure of angle 3 right there, and using algebra, whatever I do on the left, I need to do on the right, they're going to cancel on each side, and look what I have left. Measure of angle 1 on the left, which is what I have in B, measure of angle 2 on the right, which is what I have over here for B. So how did I get from statement A to statement B? I subtracted. So you would write over here, you could write subtraction property or subtraction property of equality is the most correct way. So don't forget that of equality part at the end. All right, now for statement C, we want to say, okay, does statement C come from statement B, or maybe does statement C come from putting statement A and statement B together? That's one thing you want to take a look at. Okay, but we know that statement A flowed into statement B, and if we look at statement B and statement C is saying the measure of angle 1 and the measure of angle 4 are the same, the measure of angle 2, the measure of angle 5 are the same. I wouldn't really be able to conclude that from statement B. So let's take a look at the picture. Let's see if we can figure out what the reasoning is for statement C from the picture. If I look at the picture, I can see that angle 1 and angle 4 are vertical angles, and I do know that they're equal because if they're vertical, they're equal. Okay, so the reason I know that these two are equal is because they are vertical, and I can tell that just from looking at the picture. And then angle 2 and angle 5 are also vertical. And for now, I'm going to put 2 tick marks. I don't know, that they're the same yet. Oh, actually, I do, because if we think about, and that's okay. You can put, you can think about it, put a few steps together. You'll see, this will help us see where we get from part D. I know that angle 1 and angle 2 are the same, right? So if I had put one mark on angle 1, then I definitely want to just have one mark on angle 2, one arc there. So let's delete one. And because angle 2 and angle 5 are vertical angles, I would also put one tick mark there. So let's take one thing at a time, though. The way I got just for statement C that angle 1 and angle 4 are equal, angle 2 and angle 5 are equal, is just because they are vertical angles. So you can write vertical angle theorem or vertical angles. And then, like we've already talked about, well, that's going to help us conclude, yeah, angle 4 and angle 5 have to be equal. Why was that? Well, what you're really doing is you are taking statement B and statement C together. And what you can do is, we know that in statement B, angle 1 and angle 2 are equal, right? So what would happen if I put angle 4 in there for angle 1? I know angle 1 and angle 4 are equal, so I can replace angle 1 right here with angle 4, okay? And up here I have angle 2, well, part C I figured out angle 2 and the measure of angle 5 are the same. So what if I take angle 5 and I put it in over here? Well, I'd have the measure of angle 4 is equal to the measure of angle 5, and look, that's what I'm saying in statement D. So how did I get that? Well, what I did was I took angle 4 and I substituted it into this equation for angle 1. And I took angle 5 and I substituted it into this equation for angle 5. And I'm just writing the conclusion of that. Okay, this is just the conclusion of that substitution process. And so, the reason that you can get that angle 4 and angle 5 are equal is by the substitution property. Okay, and you can write of equality to make it most correct. But for sure, get the substitution property part in there. Definitely need that part. And then you're done, because your last statement is this proof statement right here. Okay, let's try problem 32. In problem 32, we are given that the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. We want to prove that angle 3 and angle 4 are equal. So statement A should be the easiest one, right? This information right here was given to you, and so that's the reason that you know you need to put it in a proof. And now let's take a look at statement B. Angle 2 is congruent to angle 3. So first ask yourself, can I figure that out from statement A? Not really. Okay, so take a look up here at the picture. Can I figure it out from the picture? Is there something that I know is true? Yeah, there is, because angle 2 and angle 3 are vertical angles. And I know that vertical angles are equal, so I can conclude that angle 2 and angle 3 are equal because they are vertical angles. So my reason would be vertical angles or vertical angles theorem. Okay, now from statement B to statement C, there's not much difference. The difference is that you took off the squiggly over the top. This is called the congruence sign, or the congruent symbol. We would say angle 2 is congruent to angle 3. Here there's just an equal sign. And then you have the m's in front. So this would read as measure of angle 2 equals the measure of angle 3. And all you put, if that's the only change that's made, is the angle congruence postulate. Okay? And it's just really a notation change. You know, most people understand that statement B and statement C kind of mean the same thing. When we're talking about statement B and you see the congruent symbol, you're talking about the physical angles. For part C, you're talking about the actual degree measures of the angle, so like the number part of the angle. So that's the difference. And really it's a pretty minor difference, but when you do see that, and it can go either way, so say statement C was up here and statement B was down here, you would also put angle congruence postulate. Okay? Okay, so let's look at statement D. Statement D, we have measure of angle 1 plus the measure of angle 3 equals 180 degrees. Okay, so how did I get that? Well, like I keep repeating, the first thing to do is kind of look up above. Look at these statements. Maybe it might just be from statement C. Maybe you need to put a few of these statements together to get to statement D. And in this case, we're going to put statement C and statement A together. Okay? If you look carefully, statement D is really the same thing as statement A, except right here, instead of the measure of angle 2, we have the measure of angle 3. Well, why can I do that? If we look at statement C, we figured out that the measure of angle 2 and the measure of angle 3 are equal. And so what I can do is I can take the measure of angle 3 and I can put it into that equation in place of angle 2. If I do that, that's how I get statement D. So how did I get to statement D? I substituted. I substituted angle 3 into this equation in place of angle 2. But the reason that you can write statement D is the substitution property of equality. Okay, let's take a look at statement E. Now, statement E and statement D are really similar. So you might be thinking, okay, well, did I somehow, know that angle 3 and angle 4 were equal and I substituted in angle 4? That's a good thought if you were thinking that. We don't know that, though, so that's not how we got to statement E, but that's not a bad thought. If we go up and look at the picture, because that's the second thing to look at. So if you look at the statements above and you can't quite, make this work, go look at your picture. Okay, if we look at the picture, we have angle 1, we have angle 4, and we've talked about those before in this recording, that those are, they're called adjacent angles as well. They share this side, okay, but the more important thing is that the sides that they don't share, they make this line right here. So angle 1 and angle 4 are a linear pair or are supplementary, and those, anytime you have a linear pair or supplementary angles, they're going to add up to 180. So we knew this from looking at the picture, that angle 1 and angle 4 are a linear pair, and by the linear pair postulate, we know that if you add them up, they equal 180 degrees. Okay, to statement F, we have that the measure of angle 1 plus the measure of angle 3 equals the measure of angle 1 plus the measure of angle 4. All right, how did we know that? Well, we're going to look at D and E. If we put those together, we actually get F. And the way you do that is you take statement E. We know that angle 1 and angle 4 added up equal 180. I'm going to plug that in to this equation in statement D. I'm going to plug angle 1 plus angle 4 in there for 180. Okay, so 180 is not there anymore. The measure of angle 1 plus the measure of angle 4 is in there now. And if I have that, well, voila, that's statement F. Okay, so I have the measure of angle 1 plus the measure of angle 3, just like I did in statement D. And then I'm going to take this and I'm going to plug it in over here on the right side because I know that that's the same thing as 180 degrees. And that's what you get. Measure of angle 1 plus measure of angle 4 on the right side. Okay, and so what did I do? Well, I substituted, okay, or you can use transitive property. So transitive property would also work there. So either one, whichever one makes sense is okay. Transitive property, substitution property are really interchangeable there. All right, last one. We're almost done. How do we know angle 3 is equal to angle 4? Okay, look at statement F. See if you can figure it out. I'll give you a second while I change colors. Do you see it? It's really the same thing except for angle 1, right? So what if I subtract the measure of angle 1? Boom, those are gone. I have angle 3 and I have angle 4, and that's all I needed because that's what I was trying to prove. So how did I get from statement F to statement G? That's what you put over here for the reason for statement G. You ask yourself, how did I get to statement G? What did I do to get to statement G? I subtracted angle 1, and so that's what you write for your reason over here for statement G, and then you're done. And one more thing I want to add before we stop is never, ever, 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 ever write prove as a reason. Given is a reason, that's okay, but prove is never a reason. Prove is just what you're trying to show is true. But you have to use something else to get there. So I hope this helps, and I will talk to you later.